Okay, so today we're going to talk about compositions of transformations. And so first of all, we need to define what a composition actually is. A composition is just one transformation applied to a figure and then another transformation applied to its image. So basically it's like two. Okay, so you do one transformation, then another one. Okay? So let's go ahead and look at, Let's go ahead and look at this one. Okay, I don't know if you'll necessarily need to write this down or if you just pay attention. It says triangle ABC with vertices A, -1, 0, B, 4, 0, and C, 2, 6. So I'm going to go ahead and plot those. Here is A. Okay, B is right here, and C is right here. Okay. It's first translated by the rule xy goes to x minus 6, y minus 5. So do we remember how we do that? X minus 6, y minus 5? What do we do?
Pick the point and
Yep.
subtract 5 from its x, and 6 from its x, and 5 from its y.
Okay, so if I subtract 6 from its x, what does that mean that I essentially do?
Move it to the left.
I go to the left, 6, and down 5. So here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So here's my new A. And remember we call that A prime. That one tick mark means that's your first transformation. So B, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So B prime. And then 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. So right here. So here is your image of your first transformation. Okay, now it says then its image is translated by the rule xy, x plus 14, y plus 3. So what does that mean that I do with each of the light blue points?
Add 14.
Go 14 to the x and then what?
Add 3.
3 to the y. So here we start with A. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I go up 3. So here's A double prime. And what that 2 tick marks means is that's your second image. Okay, so B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then 1, 2, 3. So here is B double prime, and then C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, and then up 3, 1, 2, 3. So there we go. Now it says what single translation is equivalent to the composition of these two translations. So single translation means xy goes to. So basically, what do I do to x and y in the purple to get the pink?
Subtract 14, subtract 3.
So what do I do to A here to get A double prime?
Add 9
Plus-
to
So
x,
1, 2, 3, 4, 5, 6, 7, 8.
add 8 to x, and then subtract 2
2.
from y.
So really it'll be x plus 8, y minus 2. Let's double check that to see if that works from C to C double prime. 1, 2, 3, 4, 5, 6, 7, 8, and then down 2. Okay? What single translation brings the second image, so the pink image, back to the position of the original, back to the purple? So what do you have to do to the A double prime here to move it back to the A?
Subtract 8 from x and add 2 to y.
Okay, so I've got to do the opposite. So I've got to subtract 8, and then what do I have to do?
Add 2 to y.
Add 2. Nice job. You understood how those related. Okay. Questions on that? That's kind of what you're going to be doing today. All right? So real quick, let's go ahead and look at page 384 of your book. page 384 of your book. Go ahead and start looking at that.
We have moved 100% more than what we carried to. We have 46%. She probably came. She's happy for us.
So as you look at page 384, you can see kind of the patty paper experiment. Okay. So as you look at that composition of the two reflections, what is that the same as? A single what? A single what? Let's go ahead and look. If you have your first figure going all the way to step 5, what does that look like it is?
Minus
A slide, which is called a? Translation. Okay. In addition, the distance from any point to its second image under the two reflections is twice the distance between the two parallel lines. Okay, and that should make sense because you went twice that distance. Okay, if you're done writing that down, we are going to do investigation 2. So some of you, if you want to start writing down that other conjecture on page 385, you can go ahead and do that. On with the next one. Okay, so now, reflection across intersecting lines. This is on page 385 in your book. It says a composition of two reflections across a pair of intersecting lines is equivalent to a single what? And so if you look at their diagram on page 385, if you look at their diagram on page 385, what is that equivalent to? A what? Oh, somebody said over here. A rotation. Okay, because a rotation means it's rotated. So this is actually equivalent to a single rotation. The angle of rotation is, what do you think?
90 degrees.
No, I know, but what do you think is, what would go in the blank here? Just for kicks.
100.
Twice, just like the one before. Twice the acute angle between the pair of intersecting reflection lines. Because you're essentially doing two reflections, right? So it would be twice. Okay, there's one other definition that we're going to talk about today. Okay, and that's what is known as a glide reflection. And a glide reflection, if you look at that, those are examples of a glide reflection. It's an isometry that is a composition of a translation and a reflection across a line parallel to the translation vector. Okay? A glide reflection is a lot more easily identified than it is defined. Okay? So it's an isometry that is a composition of a translation and a reflection across a line parallel to the translation vector. So if you look at that, you can see with the feet how a glide reflection works. It's basically a reflection with a slide, a reflection with a slide. Same thing with the vines on the branch. Okay, it's a reflection with a slide. Okay, and that should make sense. So now, what we're going to do is your assignment is in the next section, section 7.3, and we're actually going to learn about something known as tessellations next week, and we're going to do a tessellation activity. But your assignment on page 386 is to do numbers 1, through 7. Okay, 1 through 7, and that is due Monday.